All right, okay. Here's a video on graphing a trig function. Okay, this is a sine. And remember, it is worth memorizing that a typical sine function looks like an S for the first 5 key points, okay? Again, obviously it goes forever. Cosine looks like a cup for the 5 key points. So high, mid, low, mid, high. Okay, so graphing, it's super important that you know the high, the low, so you can get the mid. And then you also want to know your units on your x-axis, like what kind of angles. And remember, with a trig function, your input to your function is some type of angle, right? And then your output is the ratio, okay? Now, sometimes input can be a little bit different. A lot of times in trig functions, the input might be time, and you're like, but there's no angle in there. And what's going to happen is what's going on in here is going to have a pi over here and a pi over here. So in a sense, when you do the math, those go away. And so then your input might be 1 second, 2 seconds, 3 seconds. That can happen. Okay. But in general, when we think of just a normal trig function, input's angle, output is ratio. All right. So I like to deal with output first just because I think it's a little easier. All right. Here is your function right there. That's your sine function. So that's going to spit out output. Now, normally, right, if we're dealing with range, it would be that. Now, again, ignore the negative. Just take the absolute value because you're going to just scale it by 2. Excuse me, -2 to 2. And then this is also happening to the output. So, and remember, it is what it is. So what is that, 2, 6? Okay. So 2, 6 is my range of my function. Okay, like as you go low to high, it's 2 to 6. All right. So we're done with all that. Now, what we know from the output is we know the range. We got that. We know the amplitude is the absolute value of a -2. And that's the amplitude is your distance from the mid to the high or the distance from the mid to the low. It's just that amount. And then we also know that our vertical shift, again, this is happening to the y, is exactly what it says. You are going up 4. Okay. All right. So now we're going to focus on the angle side. So let's do that next. This is a little bit more work, but again, not awful, just a little bit of algebra here. All right. So I'm going to trap it between 0 and 2 pi, because again, the point in which the 5 key points happen, okay, as far as mid, high, mid, low, mid, or high, mid, low, mid, high, the period of a normal trig function that has had nothing done to it is 0 to 2 pi. That's when it repeats the pattern, okay? That's called a period. And so we have a transformation on that. So we're going to trap it between 0 and 2 pi, but then when we undo the algebra, it will transform the period for us, which is super, super nice. All right. So to isolate, here's my function. Get rid of pi. So subtract your pi. That's a negative, by the way. Let's see, those cancel. I get 3x and I get pi. All right, and then isolate the linear part here. So divide by 3, divide by 3, divide by 3. All right, so what this does is it tells me my start and my end. Now, let's think though, this is negative. So neither one of these are quite right. It's like a sine function, but it's been reflected. So instead of an S, the normal, we're going to go and reflect it. So a reflected sine, instead of going mid, high, mid, low, mid, is going to go mid, low, mid, high, mid. Okay. All right. So it's going to follow this pattern. All right. So now I'm going to come over here and I'm going to graph it. I'll answer the questions about the angle in a little bit. All right. So what do we want for our units? Let's see. Okay. So I'm going to go. All right, where am I at here? 2 and 6. So I don't really even need, much on the negative end. So here's 1, 2, 3, 4, 5, 6. Now again, I'm only going to label my high and my low, and my mid is what am I at? 4. Did I do that? How about if I label my 2 in the right spot? There we go. So 4 is my mid, and I'm just going to put a little dash or dot there. So this is my high. This is my low, and my 4 is my mid. All right, so that's my low. Okay, I know that I should start here. Now, remember, we have to cut these because we need 4 regions, right? Like there's a space here, space here, space here, space here. So I know that this distance is going to get cut in half to get the the mid right here. That's at the halfway point, but then I have to cut it in half again to get the low and the high. So I'm going to give myself a little bit of space here. So I'm going to call this negative pi over 3. And I'm going to give pi over 3 because I know I'm going to have to cut these again. Okay. So let's do, what do I need to do? So at the mid, I am going to have a guy there because this is a sine. So that's my start. It's going to end at a mid. And halfway between, which happens to be right here, is another mid. See how I'm going to have to cut these again because I need to get that point, and they're at the halfway mark. So I need to cut again. So if you take pi over 3 and you cut it in half, you get pi over 6. So cut this in half, I get negative pi over 6. So now I know my units are going to be pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, and so forth. All right. So what do I need? Okay, halfway between these guys is going to be a low because it's been reflected. And remember, your low is at 2. And halfway between these is a high, which is at 6. Okay, so there's my, and again, try to get those so it's not pointy. It's not an absolute value. All right, so now I can keep going. Pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and keep going, and negative pi over 6, negative 2 pi, negative 3 pi over 6, negative 4 pi over 6. All right, so let's see. So I go mid, low, mid, high, mid. So the next tick mark, because I'm going by tick marks here, I didn't have to jump any, is there, then mid, and then the next tick mark's high again. So I can kind of get that. And again, draw an arrow, because it does go off to infinity. And then my next tick mark here is what? A high, yeah. And then my next tick mark would be back to mid, right? And again, that would keep going forever. All right, so I got it graphed. Okay, so now what questions do I have? So these are the questions that are dealing with the ratios, right? The output. I need to talk about my period. Probably the easiest way to get period is 2 pi divided by the coefficient of x. So I'm going to divide by 3. That's my period. Remember, the other way you can do it is count from start to end. So where were I started at what? Negative pi over 3. My 5 key points were right there. So, you could count, and be like, well, that's a distance of pi over 3. That's a distance of pi over 3. That's a distance of 2 pi over 3. Okay, it's, kind of up to you. So period deals with that. Oh, and then the other thing we care about is phase shift, deals with the input here. Again, if you do this, the phase shift is that answer right there, negative pi over 3. You are going to the left a distance of pi over 3, okay? Another way to get that is either factors, so you can see it, or set this equals 0. So if I set this equals 0, I get negative pi divided by 3. I get it that way. The other way is if I factor this, because the way it's written, sometimes people are like, oh, it's kind of like, setting factors like x plus 4 equal to 0 and x plus 5 to get the x-intercept, since a negative 4, negative 5. The problem is this isn't factored. So if you're going to just look, then you have to factor. I'm going to come down here quick. So say you get negative 2 sine, you have to factor out that. So let me do that for you. So if you're going to factor, you want to take out the 3. The problem is this guy doesn't have a 3. So you're going to force him to have a 3. So you're going to divide, you're going to put 3 over 3 because that equals 1. All right, negative 2. I'm going to factor out the 3. So I'm taking the 3 out of both numerators. So what's left there? Pi over 3 plus 4. And you can check 3x and yep, pi. Then if you set this factor equal to 0, I need an extra parenthesis, after I factor that out, I can see the phase shift is a negative pi over 3. All right, so what haven't I talked about? Oh, domain. Let's talk about domain. That deals with the angles. Everyone, okay, there are infinite many, right? So you could do all reals or negative infinity to infinity there. All right, so I think that's all the angle stuff we have to deal with. All right, okay. So this one, I don't know that I have time to do all of this, but what I want to say here is we don't like negatives in here at all. So we don't even want a negative coefficient. This is kind of a trick problem. So if this happens, you do need to remember even and odd functions, okay? And from your algebra background. Probably the best even function to remember is this guy, x squared. If you sub in a -1 or a negative x, it gives you x squared. And notice it has symmetry to the y-axis. That's an even function. An odd function, your go-to is the cubic, kind of like a disco, it kind of bends. When you sub in -x, you get a negative, you get the opposite. And this is, so opposite, odd, and symmetry to the origin all go together, okay, from like a algebra class. So if you graph sine or cosine, which one behaves which way? Well, all right, let's see. Sine looks like an S, and I'm going to, obviously keep building it. And so do you see that it has symmetry around the origin? It is an odd function. So what that means is sine of x, if you sub in a negative x, that you can actually pull that negative out. It's going to end up being the opposite. Okay, it's an odd function. And then with cosine looks like a cup. So high, mid, low, mid, high. And again, I can keep going. Notice this has symmetry to the y-axis, similar to a quadratic or a parabola. So cosine is actually an even function, okay? So it's even, meaning that if I sub in a negative x for my input, that it actually can just go away, either way. So what that's telling you is cosine of 30 degrees and cosine -30 are the same answer, okay? All right, here it's saying that if you have sine of 30 degrees and sine of -30 degrees, you're going to have negative of whatever the sine of 30 degrees is. Okay, that's kind of what that's saying. The reason this is important is because we can't have a negative here. So you have to know, oh, sine is an odd function, that this is actually an odd function. So you're going to pull the negative out front. So you're going to take a negative away from both of those. And what you're actually, and this is separate, you're just pulling it from this part, and I need my negative there. But you need to realize, like, ooh, if I take a negative out from both of these, this is an odd function, okay? Notice if this was cosine, if this said cosine here, you could pull that negative out and do nothing with it, because cosine, right, even function, not a big deal. But sine is an odd function. So if you pull out a negative out of that input, has to come up front. So then you would do your graphing, with this guy. Okay, we don't ever want to have a negative there. All right, I'm going to pause this video. I'll do another one. Let's see, I'll try to do maybe a cosine with no reflection, and maybe one of those weird ones where it ends up more like your input is like time or something like that. So I'm going to stop this one, and then I'll make a cosine one, and hopefully these help you out.